So let's just start by constructing the scatter plot. All right, do that first. The first part is pretty straightforward. Just have to graph. It's all an estimation, so you will have different answers from other people. So we got 160. We got 2950. Let's see there we go. 2950. 4240. And 4340. And 7230. 72 and 30. And 78 and 20. And right about there. And 80 and 20. 80 and 20 right there. And 9220. Lots of 20s. 9220. 9820. And 9910. There we go. So you want to draw a line of best fit, right, that goes through or comes close to pretty much all the lines. So I'm going to start right about here. And you don't want to make it like, your goal is not to make it go through as many dots as possible. It's for the line to be close to as many dots as possible. So you don't want to go up here, because then it's really going to ignore these two down here. You don't want to go down here because it's going to ignore a lot of these up here. So you try to find something that's kind of goes down the middle and a line that's close to pretty much all the points. Doesn't have to go through anything. Okay? And then the directions say state whether the to be a positive correlation, negative correlation, or no correlation. When there is a correlation, find the slope intercept form of the equation of the line that best fits the data. Okay. So next part is to, again, estimate. It's not going to be perfect, but you can look at this and estimate and say, you know what, the y-intercept is probably about 61 or 62. You know, it could be different for any person. Okay. The slope, you have to find a couple points and calculate the slope using the formula. So I could use, let's see here, something looks pretty good. Yeah, I'm going to have to estimate a little bit. You know, right about here, these points are right on my line. So I can use that one, and I think I can use this one as well. So I'm going to use a few of the points that are already on there. You don't have to, but I'm just going to pick those two and use them. So I got 60 minus 40 and 1 minus 43. That'll give me a slope. Let's see here. That's 20 over negative 42. And of course, for these, you want to get the actual decimal. So let me go to my calculator real fast. There we go. So we have 20 divided by 42, which is about, 0.48 negative. So we got about negative 0.48 for my slope. And again, you might have picked two other points. Maybe you had 2 points when you drew your line that were like perfectly like on some lattice points, like right here and right here. And you didn't have to use the actual data points at all. It'll be different for each person. And actually, I'll know if you didn't do it, because if you had the same exact thing as somebody next to you, I know you didn't do it, because it's almost impossible for two different people to get the same, draw the same exact line, and then pick 2 points on the same exact line when there's an infinite number of points for you to pick. So your answers should be different, at least a little bit. They'll be close, but they should never be exactly the same. Okay? And then, of course, write your equation here. So I have negative 0.48 x and then plus 61. Okay? So yeah, your slope should be, somewhere around there. It shouldn't be positive by any means, because it's going down. Since it is going down, there is a negative correlation. That was actually one of the first questions, to state whether it's a positive correlation, negative correlation. Okay, so it's a negative correlation. It's similar to slope. It's going down, therefore it's negative. Now this is a pretty strong correlation, so it doesn't say this in directions, but if you want to, you can approximate the R value. So you can see that this line comes pretty close to all the points. So it's a good chance that this is, the R value is maybe like 90, I don't know, I'm just guessing, 90.94, which remember that means the line comes 94% with accuracy. So most of the time, if not all the time, it's very accurate. So that was from yesterday, that R value. You don't have to do that, but just keep it in mind for your test that you want to be able to do that. On the review, it does ask for you to make a scatter plot, approximate what the R is, make sure you know what the R value stands for. It's the percentage of accuracy. Okay, it has percentage interpretation. So that is a scatter plot. Now notice how it says when there is a correlation, that means positive or negative. So when there is a positive or negative correlation, that's when you have to find this. But very similar to like the quadratics, if there's no solution, you just stop the problem. You can't really do anything else. Like if you know there's no solution, you don't need to move on. So same thing here. If you do a scatter plot and you see that the points are just everywhere, there's no correlation. Well, there's no point to trying to find the line of best fit and the slope and y-intercept, because there's no line you can draw that will come anywhere close to predicting any of these points. So for no correlation, whenever that happens, you don't bother actually finding the line of best fit or the slope and the y-intercept, because it doesn't matter. It's not going to work. Okay? So you can skip on the line of best fit. And that's why it says in directions, when there is a correlation, positive or negative, that's when you do this. If there's a no correlation, you just write no correlation and move on to the next thing, because you can't predict anything with this line. The whole idea is finding a line that can help you predict. But with the points so far away, it won't help you predict anything. So what's the point? Okay. All right. So that's what you want to do for each one. Let you actually work on 2, 3, and 4, and then I'll go over 5 in a little bit. You can also wrap up anything else that you need to on the computers. Remember, this do not do on Desmos. You need to have the skill of doing this all by hand. Also, keep in mind for your quiz, you want to be able to get these numbers, right? So you need a calculator in order to get those for your quiz next week. So make sure you have a calculator, not a phone, a calculator. Okay? Not the computer, calculator. Make sure you have your own device, not sharing with somebody else and passing it back and forth. Okay, got to have your own. And it's something you're going to need for geometry, algebra 2, any class you take coming up next year and the year after. You're going to need a scientific calculator at least. So just get it now and hold on to it for the next few years, because you're going to have it one way or another. Okay. All right. So I'll let you work on it a little bit. I'll come around and see if you got any questions. Okay. Okay. So here we go. Let's take a look at number 5. Now, this is, so on number 5 is probably the more important part of what we're doing. So after you get the slope, the y-intercept, and everything, so what? What does it mean? What can you do with it? The whole idea of this is that you can use it to predict. Once you have the equation or the line of best fit, you should be able to use it to predict something, not just say, well, I got an answer, I'm done. Right? So that's what this one is about. So I already have the scatter plot here for you along with the equation, and you have to describe, so what does it mean? Which is the more important part. Okay, so it says, what does the slope represent? What does the y-intercept represent? And then use the model to figure out, to predict something. Okay, the whole idea. So let's first talk about the slope. Remember, the slope is rise over run, right? That's what slope is. Which means it's y's over x's. So what you want to do is look at the, what's it called? the units of the y over the units of the x. Like if it was miles over here and hours down here, the units would be miles over hours, like miles per hour. That's what the slope would mean. It's how fast you're going, miles per hour. So similar here, look at these. The y is dollars, okay, GDP, gross domestic product, per capita, like per person almost, and then over the corruption score. So that's what the slope means. So as this moves, as it moves up, it means as the GDP goes up, as the corruption score goes up. That's what that means. Okay, because the line is going upward. So you can write the GDP increases with the corruption score. Now, if you read the description, a higher corruption score means less. So like 100 is the least corrupt. So don't think, oh yeah, the corruption's going up and they're making more money. It's the opposite. Okay. And this is something that economists look at worldwide. That's what economists does. It uses a lot of math, but it's more of the statistical stuff because they're taking actual countries and figuring out what their GDP is, and then figuring out a way to measure the corruption and looking for relationships, looking for patterns. Okay, so lots of math, not necessarily like solving the equation and graphing it, but just putting it into a computer and then looking at the results and trying to figure out what it actually means. So there's another side of mathematics that's much more creative. It's not like in a job that uses math is going to be like, here's 20 problems, have them done in an hour for me. It's going to be something like this where you might have to collect the data for years and then analyze the data and try to figure out what it means. And not that you're figuring out and writing a bunch of equations and solving it and adding to both sides and things like that, but you just get the answer, you get the equation from the computer like we've been doing, and you're trying to figure out what it means, and maybe you'll be advising the president or some government on what we should do policy-wise to make corruption go down and things like that. So lots of math involved, but not necessarily, sitting there and just cranking out equations. When you're talking about B, which is the y-intercept, right? So that's if we just continue this down, it will cross right here. Now they already told us right here, that's where it crosses. So the y-intercept, remember, is where 0 is x. So it's really the coordinate 0, negative 5,390. And again, to interpret this, what does it mean? What does it represent? Is to look at the units. So again, the x is the corruption score, okay, and the y is the GDP. So 0, this number is going to mean a corruption score of 0. Yeah, a corruption score of 0 has a negative 5,390 GDP. So it's simply putting a 0 in front of whatever that y-intercept number is here. Okay. And I could actually put the number. I should have done this as well for the first one. I should say it increases $400 to each corruption score. So for every score, it's counted by tens here, but for every score it goes up from 1 to 2 to 3, that means the GDP goes up $400. So it makes sense, logical sense. The less corruption, the more money that we made because it's not being stolen by whoever, criminals or politicians, and you know anybody else that can contribute to that. So the less corruption, the more money there is. That's why we try to strive to have an honest people in charge, so they don't mess everything up. Okay, and lastly, we're going to use this to actually predict and estimate. So that's the whole big picture of all this. We can actually estimate this. So it says we want to estimate what the GDP is with a corruption score of 33. So there's two ways of doing this. We can look at the graph. Right? And just kind of see it from here. 33, it's about 7,500. And the second way is to actually put in the equation, right? And see what you get. So we have y equals 400 times 33 minus the 5,390. And I think that comes out to like 7830. So they come out pretty close, but yet they're still different. So two ways of looking at it, either estimate from the graph or from the equation. In general, you want to use the equation. It's going to be more accurate. Okay, just eyeballing it and looking at the graph, not so much. So use the equation, but it should be close to the graph as well. They're somewhat similar. Okay. Okay, so you want to finish that up and turn in anything. I'll be going over all those homeworks that you've turned in on from Desmos on Schooloop. And try to be here Monday because it's a big block. We're going to go over the second half of your test.